So malicious software or malware. So it's software that infects owner's machine without consent of that user. It's a general term that refers to a wide variety of damaging or annoying software. So these are the objectives of malware. If you have a virus of malware, its goal would be first to infect, second to hide itself, okay, and third to do the malicious component, basically the harmful component. So bring profit somehow. Okay. So you know, there are a lot of types of malware. Every day we have a new name for a malware. Okay, so whenever you see something that ends with ware, it's something, you know, it's a new type of malware. So this is an example of classification. Okay, it contains the major types of malware. So we have here trapdoors or backdoors. Okay, sometimes we call them backdoors, sometimes trapdoors. Logic bombs, Trojan horse, viruses, war, and zombies. So we will go through them one by one. So here it tries to classify them somehow. So here it says that needs host program. So all these trapdoors, logic bomb, Trojan horse, and viruses, they need another program to infect. So they are not standalone. They are not a singular program that just fits the malware. It is, sometimes we call it parasitic malware. It's a parasite. Okay. So basically, to work, these programs needs to infect other programs, other legitimate programs. Okay. And then you have standalone or independent. So they don't need any other. They don't infect other files. They will execute their payload without needing any other program. And we can also classify them as replicating or non-replicating. Replicating, basically, they will try to replicate themselves automatically, without having the attacker, infect every new user or every new victim. Okay, so viruses, war, and zombies are self-replicating. So they will replicate them. They will be programmed to infect other files automatically. Okay, other files or other machine hosts. These are not. So basically, you need to infect the attacker or the hacker that needs to use them needs to infect every victim apart. But this classification nowadays you don't have a malware which is just, for example, a logic bomb, and that's it. It stops there. Okay, or malware that is just a virus. Okay, the malware we see in the wild are a combination of some features of each one. So this is why most of them they are called hybrid malware. So it will have some worm feature, some logic bomb features, some virus features, like that. Okay. So the first one, backdoor. Backdoor. We're gonna see an example if we have time. Backdoor is an entry point to a certain host or certain victim that doesn't need the typical authentication credentials. Okay, so a backdoor, most of the time, it is used by attackers when they do all the way to successfully hack into a machine. In order to avoid going through all that process the second time, for an attacker, for the second time he wants to come back, in order to avoid the same process that he did the first time, he will open a backdoor in the system so that the next time he will just use that backdoor. Backdoor is basically, most of the time, it's the open port in the target machine. Open port that allows him to get inside without going through, cracking or all the process. Okay. So the general idea, how to implement it, we have, of course, different ways of doing this. Logic bomb. Logic bomb is a small piece of code that is hidden in a large software. Okay, and the interesting thing is that it will not trigger. So basically, it will be waiting, dormant, like idle, waiting for some event. When that event happens, it will execute, it will launch. Okay, so it's very small. Okay, and it might last for a long period of time, just waiting. Okay, then if a certain event, for example, if the user launches a certain program, okay, or if a certain date, if we reach a certain date with a time, okay, what happens to Aramco a couple of years ago? It was a logic bomb. It was programmed to trigger at I remember August 12th, August something, August 18 or 12, 8 a.m. 8:08 a.m. exactly. Okay, it triggered. Okay, so this is very difficult to detect. Why? Because most of the malware we're gonna see, in order to detect them, basically we detect them according to their payload. When they start harming, when they start deleting file, harming this or stealing file, you can notice the symptoms. Okay, but this one, it doesn't have any symptoms. It's waiting. It doesn't do anything. It's just checking the event, checking the time. So it's Shamoon, the virus that hit Aramco. It was having a loop. Every second checks the time. Every second checks the time. Checks the time, and that's it. It doesn't do anything. And when the time comes, it triggers. So it's very difficult to detect, and it is typically used by disgruntled employees, which has been fired. So basically, before when he got fired, before he leaves, he will place that logic bomb somewhere in the code, and then it will go. Okay. So after a couple of weeks, it will blow up. Okay. Trojan horse is similar to logic bomb. Basically, a Trojan horse is you're gonna see it's a feature very common and used by other types of malware. It's a malicious program that is hidden inside a legitimate program. As simple as this. Okay. So sometimes you download a game in a program. You think it's a game. It's a game. So if you launch it, it will launch the game. But in the background, it will launch the malicious part. Okay. So Trojan horse. A virus which is basically sometimes we use it as the term is used as substitute for malware. Okay. Sometimes virus we use it to mean the malware. So a virus. It's a piece of software that infects a program, modifying them to include a copy of the virus, so it executes secretly when host program is run. So it's a malicious program that will infect other clean programs, okay? And it has a process. So once it infects a certain program, of course, it will only execute if the legitimate program executes. So for example, if it infects word.exe, Word is very common dark. Okay, Word.exe its size will be a little bit larger because it has other malicious features. Okay, then whenever you execute Word, the virus will execute. Okay, yes.
Is it the same as a Trojan?
No. Both of them are parasitic, so they will bind to another file.
It doesn't have to be downloaded with or installed with Word. It can be installed afterwards.
The logic bomb, the attacker is in charge of binding the malicious program to the legitimate one. It is done only by the attacker, and then he will spread that file. Okay. Now the virus, the hacker doesn't bind. That doesn't do the binding. It's the virus itself that will bind itself to other legitimate programs. So in the process of infection and replication, the virus will do that. But in the logic bomb, the attacker, while he prepares a nice piece of code, he will choose a game program or movie or something, and it will bind it to it. Okay, so but again, both of them are parasitic. Now, the virus goes through several steps: dormant, propagation, triggering, and execution. So this is components: infection, trigger, payload. Because we have the program pseudocode of a virus later, but let's discuss about this. So infection mechanism. This is the mechanism to infect other files. Now, suppose you have the virus infected your machine. Okay, so you have one file which is infected. Then, when you execute that, you double click on that file. What will happen? Of course, the legitimate program will execute, and then in the background, the virus will execute, and it will try to infect other what? Other programs in the same machine, very important. Okay, so the malware or the virus has an algorithm to do that, has a process. Basically, example of process, it will go to my documents, okay, folder, and then we'll look for all executable files in the my documents folder and infect them one by one. Okay, all viruses have an algorithm of infection. Okay, it needs to choose which files to infect. It cannot infect all the files. It takes too much time. It has an algorithm. Okay, it might go to the office folder and look for all executable and infect them one by one. So it has an algorithm. So this is the infection mechanism. Trigger, this is the event that makes payload activate. So basically, the event where the malicious parts start executing. Okay. The payload now. The payload, what it does, of course, is the malicious part. Now this is the issue: prepend, postpend, and embed. When I say that word.exe is infected, so word.exe, let's say initially, it was, let's say, 1 megabyte. Okay, the size of the file is 1 megabyte. Okay. Now, after the infection, we said the size will be large. Okay, size will be large. Now the question is, this is word.exe. Now, where the malware will be, because the malware will be added to the executable. Where? Huh? What do you mean?
At the beginning of the file.
So this is why we say prepend, postpend, or embed. Okay, so it might be added here, or maybe okay. It might be added here. Okay, and also if you can do it in the middle, you can. Okay, so but these are technical aspects. Okay, now what is the advantage of adding it at the beginning?
It can be easily detected, I think, by.
It is not easily. It is a little bit easy to detect, okay? Because it's in the beginning of the file, okay? This is a disadvantage from the attacker's point of view. But from the attacker's point of view, what is the advantage of doing this?
It will be executed first.
It will be. So basically, when you launch word.exe, the first thing to execute is the malicious part, and then normally the word.exe will execute. Okay, so here the control flow is natural. Okay, what if you put it here? The malicious part, the virus, needs always to execute before the legitimate one. Okay, so if you put it here, now if you run this program, word.exe will execute first. Okay, and here the word.exe, after it finishes, you need to program it to go to the malware, which is not easy. Now, always viruses or malicious parts are executed before the legitimate part, even the logic bomb, not logic bomb, the Trojan horse. Okay. So here, what it takes to do this, because here it's appended or post-pended. The virus is post-pended. How to make it work?
You modify the address, the return address of the.
Not return address. So basically, you need to. There is a starting point here. There is an address that specifies where the program should start. Okay, this is in the header of the executable. You need to go to that address, and replace it by the starting address of the malware. And then when the malware finishes here, the last instruction should be jump to that address. So it's a little bit more technical to do, okay? So yeah, a lot of aspects are related to infection mechanism. This virus version problem. Can block initial infection, okay. So this is the pseudocode of the virus execution. So we have here infect executable. This is the process of choosing which files to infect. So file here, get random executable file. So here this function will take care of choosing the next target to be infected locally. The virus is always infects in the local side, not in the outside. So here, go to loop and prepend v2 file. So here this infection, do damage. This is the malicious part, and then the trigger, which is the event when the payload is executed. At the end, when we finish, so this is the main infect executable. It starts with infect executable, calling this. Then the trigger and the do damage, and at the end, what it should do? Go to next here.
The beginning of the program.
So after it does the malicious part, it needs to start the legitimate program so that it looks normal. Okay. Now, one way to detect infection is that you notice that the file increased, the size of the file increased, right? Okay. Now, if you need to make, or the virus or the attacker needs to make the infection stealth, secret, not easy to detect, he needs to make sure that the file size does not change that much. Okay. So this is why there are a lot of techniques to do that, but one way is to compress. So use compression. Compress the malicious file and the legitimate file also. Okay, to make it smaller. Okay. So use compression. This is one technique, but you can also overwrite. Use overwriting. So here, instead of prepending or appending the malicious part, you can overwrite some content in the middle of the program. But what's the problem of doing this?
Disable some features.
Yes, the program might have an abnormal behavior. Okay, might have. But there are techniques that allows to overwrite without changing the behavior. For example, you can use, let's say, empty spaces. So, but empty spaces, you need to have a large enough empty space which is contiguous to add the. But even if you don't have a single contiguous space, you can still do it, but very advanced technique. But the goal here is to make the size not very different from the original one. Virus classification, we have boot sector, file infector, macrovirus, encrypted virus. Boot sector with the name means what?
So
it is there to infect the master boot record of the disk, okay, which will be which makes the virus run as soon as you launch your operating system. Okay, very serious one. File infector, this is what we were discussing. Macrovirus. What is this? No. Macrovirus means what? No. Huh? No. This virus, it targets programs or software or files that have macros inside them. Example of programs with macros. Office. Excel is a known program software whose files that use macros. So macros are pieces of code that execute. So when you launch, you open that Excel sheet, there is a program that is run. So a macrovirus is a virus specializing in infecting Office, or not only Office, even Adobe, PDF. PDF, you can have scripts there, same thing. Okay. So macrovirus that infects, it doesn't infect executables, .exe. Okay. It infects programs with or files with macros. Okay. Encrypted virus. encrypted virus.
Any virus can be.
Again, this Malware lecture last year, I gave a graduate course about malware. So it's a full course about this. All these aspects can be discussed in lectures, complete lectures. So here, this issue, encrypted, stealth, polymorphic, and metamorphic. Okay. So let's talk about encrypted virus. What is encrypted virus?
Virus
Finds itself by encryption?
Huh?
Finds itself by encryption?
Yes. Yes. So it encrypts itself. What is the advantage of encryption? It bypasses antiviruses because antiviruses, they have a signature for every malware. Okay, every virus. So this encrypted virus will encrypt itself in every infection. But if it encrypts itself, once you want, it infects the machine and it needs to execute. Can it execute in encrypted state? It needs to decrypt itself. How it decrypts itself? Because when we say encrypted virus, it seems to you that it's like encrypted communication. In encrypted communication, you have a sender and receiver. The sender will encrypt the data and send it. The receiver needs to decrypt the data in order to understand it, right? And both of them, they use keys for doing that. It's different because the encryption and decryption, is it done by the receiver?
No, the virus.
The virus itself. So it should be self-encrypting and self-decrypting. You see? So basically, if you have your malware, an encrypted malware, you will have this is the body of the malware. Okay. And suppose it's encrypted, okay? Once it's encrypted, in order to decrypt, you need to have a decryption loop. Somewhere in the program, somewhere in the virus. And the decryption loop, can it be encrypted?
No.
It is not encrypted. It cannot be encrypted, because if it is all encrypted, this is a garbage file. It will not execute anywhere, okay? This is just a bunch of bytes, that's it, okay? So there is a decryption loop, okay? Now, encrypted virus is a virus which is encrypted but the loop is not encrypted. Okay? Decryption loop. Now, is it for an antivirus software? If it needs to detect such virus, it should have a signature, right? Can it have a signature on the encrypted part?
No.
It can't. Because it's encrypted, each time it will have a different format. Okay. What about the decryption loop?
Yes.
You can build your signature on the decryption loop. Okay. Now, since all the same virus will always use the decryption loop, it might be used as a signature, and it's the antivirus can detect always that malware. This is why we have polymorphic. Polymorphic virus is an encrypted virus, but the decryption loop, it changes all the time. You will use different decryption loop each time. Okay? So here, the decryption loop, it will do the same job, but you will have some different instruction all the time. And it is easy. If I tell you, for example, instruction x plus 1, okay? You can do the same job by having x plus 3, then x minus 2, right? You will have the same result. So it is easy to mutate, this is mutation, mutate any instruction using different transformations. Okay? So polymorphic virus, it will use that trick. The decryption loop will change all the time. Now, metamorphic virus, it will basically do this mutation. Metamorphic virus, first of all, it's not encrypted. It is not encrypted, it's plain text. But it will be metamorphic, meaning that all the malware code will change in every infection using these tricks. Okay, so metamorphic, it changed the shape of the virus completely, the complete code of the virus. Okay. Anyway, so these are small tricks used by viruses. Not small; it's very commonly used type of bypass of antivirus products. Now, worms, virus. Yes.
And for the stealth one, how can
Stealth. Stealth basically it's what does it mean stealth?
hidden?
Huh?
Massively hidden.
Yeah, it tries to hide itself. Okay, so stealth features of a virus, they are done what we call rootkit. Rootkit is a small utility just for hiding the symptoms of malware or viruses. I have a slide for that. Rootkits, just rootkits. Okay. Worm. Virus is self-replicating, but it is self-replicating locally in the same host, in the same machine. Now, worm is self-replicating, but not only in the local host, it will replicate in the scope of the network. So, a virus doesn't infect other machines in different hosts. This is the job of the worm. Okay? Worm, its job is to infect the maximum number of users or hosts in the network, and sometimes a worm, in a lot of situations, the worm doesn't hurt, doesn't have harmful payload. All its goal is to infect so many users so that you will take most of the bandwidth of the network, okay, and reduce the efficiency of the network. This is its goal, okay. But it might have, of course, malicious payload like other malware, okay. Rootkit. This is basically when you need to write malware in previous semesters. We had homework assignment about writing malware, writing a virus with rootkits, etc. Okay. Now, students didn't have a hard time to write it because writing a malicious software is easy. It is easy. Okay. If I tell you, okay, write a program that will delete or format C. How many lines to write? Format C, which is huge.
Loop all the file like.
Format C. What do you need to do?
It's command line.
Command line. Three instructions. Okay. Very easy to do. Keylogging. You did the so keylogging also in Python is 10 lines of code. 10 lines of code. So writing a malicious program is easy. Okay. But what is difficult? What is difficult? What is the challenging part? Yeah. So bypassing security products, hiding from the operating system, this is the difficult part. And this is done by this utility, it's a rootkit. Rootkit is just in charge of that, okay? And it does it in the right way, okay? So the rootkit's goal is to hide the presence of other types of malicious software. Now here, rootkit, it needs to work at a very low level. So it needs to cheat on the operating system, okay? So for example, it might change the behavior of system calls, okay? So for example, you have a malware, a virus, for example, which is, not a virus, a worm, let's say. A worm, which is in a certain folder, okay? Now if you go and you browse to that folder, normally you should see that malicious file. Now the rootkit, what it can do? It can change the behavior of your Windows browser so that when you list the list of files of a certain folder, it will filter them. In some files, it will not change. Although they are in the memory, they will not display it in the Windows browser. Okay? So it will cheat on the operating system because antivirus product, it uses operating system features, system calls, right? The antivirus relies on the operating system. If the operating systems keeps giving wrong information, missing information, the antivirus will be fooled. Okay, so the goal of the rootkit is to change the behavior of operating system at a low level, so that to cheat on the OS and the antivirus. Now let me show you. Example of rootkit and how it works. I'll show you a very common type of let me see here. Yeah, here. Here I have netcut. You know what netcut, right? Who knows netcut? Who knows netcut? Now netcut, NC, it is a backdoor. It is a known backdoor. It's basically, we call it the Swiss Army knife. You know what Swiss Army knife?
Not typically uses.
You know, Swiss Army, which has scissors as a knife, it has everything, you know. It's the Swiss Army knife of TCP/IP. You can craft any packet of TCP/IP using netcut. So, and you can, for example, use it as a tunnel. You can use it as a server. You can use it as a backdoor. You can use it to open ports. Okay, so it's very useful utility. So here I will use netcut to create a backdoor. Okay, I will use netcut to create a backdoor. Basically, I will open a port of this in this machine, in this Windows XP. I will open a port, and anybody can connect to that port and get access to the system. So the instruction would be NC. So NC. Larger. Okay. So NC dash capital L dash C dash D dash E, and then CMD dot exe, and then dash P, let's say 6,000. Okay, so according to this instruction, we'll do what? It will launch NC to open port 6,000 dash P 6,000. Then for every connection to that port, it will give the command.exe. So basically, this is a backdoor to give the remote command line. Okay, remote. Okay, so this is very simple. Backdoor. Okay, so here enter. Now this is the backdoor. Now a malware that will execute on this victim if he needs to open backdoor, he needs to execute this instruction. Okay, if he needs netcut, and it is very commonly used, by the way. Okay. Now if you go, let me open another command line, and then. Then I will check, for example, what the list of processes running. The list of processes, okay? Because sometimes if I have an idea, if I know netcut, or the operating system might be programmed to, if you see netcut process running, you need to do some action, block it or do anything. Okay? So to list a set of processes, what is the command line instruction? Task list. Task list. Okay. Task list, you're gonna see nc.exe. It is there. So there is a process called nc. Okay. Now, if I need to see the list of open ports of the local machine, what should I do? Netstat. So netstat dash A for all netstat. Okay, and you're gonna see port 6,000. So if you just dig a little bit, we will see the symptoms of this backdoor. Okay. Now I will use a tool to hide that. Because here we are playing with the operating system. Okay. So hiding the process, normally it's not possible, right? You cannot. This process is process. So it's the operating system will find out. But there are tools or rootkits that I will be using right now. So here, another one, and then this. Okay. Okay, CD HX. So this is the rootkit is called HXDev Hacker Defender. At some point, you know, in 2006, 2007, it was the major rootkit used by most of malware. They used it to hide from the operating system. Okay, there you go. And the point is, the source code is available. It's open source, not open source, but the source code. I don't know. I checked in 2011; it was there, but since when I can tell you. Now, what you need to do in order to use this hacker defender, you need to configure it. So here, HXDev, and then you need to open .ini. Where is it? I think this one. Wait a minute. HXDev 4000. This one is. No, yeah, this one. Yes. Okay, so open. Yes. So here, see. Here you configure your backdoor, your rootkit. You configure it to hide particular information. Okay. So for example, here you can hide hidden table. You can hide processes. So hidden processes. You specify the file you need to hide. Okay. And or the process you need to hide. Okay. And then root processes. It's like you need to hide something to type it here. Okay. And here, for example, what is it? Hidden ports. Okay, hidden ports. TCP port here 9,000. We need to change it to 6,000. Okay. Now, question here: why it is written with junk characters here?
Event detection.
You know, see, hidden we have this character, then hidden also we have like random junk characters. Why? Huh? It is readable. It's readable. It's fine. We can do. Huh? Sorry?
The same technique we discussed last lecture. It's like preventing against.
It was we covered filters, but here, bypassing antiviruses that will scan according to these strings. So they will be bypassed. Okay. So let's open. So here we save the file, and then let's execute it. So here to execute, just I need to type. It's very okay. HXDev exe. That's it. Okay, exe. Okay. Now, if you go back and execute the same instruction again, okay, so here, you want me to open a back, let's open a backdoor to be sure. I have another machine. Here. I will open a command line. I have netcat also here. So here I have okay, cd, and then here, where is it? CD hacking tools, CD netcat. I think here is config. It is 103. So here, all what I need to do is execute nc. So let's see this nc.exe, then dash 192.168. Dot what? Huh? Which one? 56. 56.103. Then I think nc dash p 6,000. Okay. Oh, nc unable to connect to
No ports.
no ports. Okay, not 6,000. nc.
No, I don't know.
Huh? $56,000. Okay, that's list. It's not there. Here, let me see. IP config. Yeah, it's a different network. Yeah, this is one. It's not. Anyway, so I wanted to show you that how I can open remote shell on the other one, but here they are on the same network. I forgot to configure. Anyway, so here, CLS. I programmed the Hacker Defender to hide the process and the port. Okay, so now if I do task list, do you see NC? It has been hidden. Although the process is there, but it's hidden now. The operating system have been fooled. Okay. Same thing. If I do a net start, do you see 6,000? There is no 6,000. Right? Yeah. Although it's running, it is there. So if I shut down Hacker Defender, so here, where is it?
But I can't find it also in the.
You can't find what?
The Hacker Defender in the commander.
You couldn't find it.
Yeah.
On the task list, I mean.
Test list.
Huh?
You can't find it.
But those are running processes.
Yeah. Hacker Defender, of course, it hides itself also. Yeah. Install here. Install. Okay, so now if we repeat the same thing again, because now I shut it down. Task list, I think it takes some time. Task list, you haven't seen it's back. Yeah, it is back. So yeah, so these are really important parts of the malware lecture. Spyware. It's a malware that will try to steal sensitive information on the users. So you see, if you see a browser like this. So whenever you have the toolbar or some feature which is free and very nice, etc., keep in mind that there's a high probability that there is a spyware behind it. Okay. Same thing, adware. So most of these also adware. So adware, it's a malicious program that will launch a lot of advertising pop-up menu, pop-up windows to advertise so many things without your consent. Botnets or zombies.
But the network and zombies are the machines.
Yeah, so here, if you use, for example, logic bomb or a backdoor or Trojan horse, you will be infected just one single victim, right? If an attacker can infect tens and hundreds and thousands of victims, he needs to control them, not separately. He will have a network of them, and he will instruct them, for example, to launch a denial of service attack on a certain other target. Okay, so if you have a large number of victims infected, this is called the botnet, and the victims are now called not only just victims; they're called zombies. Okay, so most of the time the network or what is called the attacker machine is called what in this scenario? It has a name. If you have 1,000 zombies, okay, infected machine, which is it's a very common problem, botnets, very common problem, okay, and they have an estimation that 40% of machines, 40% machines are infected with zombies. It's part of botnets. Okay, so 40%, if we do a small computation here, a little bit less than half of you are infected right now, and I truly believe it. Although you are computer science or students or software engineering, but statistics are statistics. Okay, so what is the name of the master, the one who is controlling them?
Bot herder.
No, bot herder, yeah, but the server in the malware terminology is called the CNC. Controller. Very CNC. This is if you go to a blog on cybersecurity CNC. This is command and control server. Command and control server. Okay. hybrid. The idea, as I told you, now we don't have just malware, which are just virus or just war or just a logic bomb. They are mix of several features. Okay? It's a hybrid